Okay, welcome back, guys. We're going to be solving two more questions from the second chapter of the fundamentals of electric circuits. And we have question 13 and 14. Let's start with the first one. So for the circuits that we see on the right-hand side, we need to use KCL, which is Kirchhoff's current law, to find the branch currents I1 to I4. So we have 6 I's in here that we need to figure out. So I1, I2, 3 and 4 in here. So based on the Kirchhoff current law, so basically we're going to pick different nodes in here, and the sum of currents entering that node and exiting has to be equal to 0. So let's see the nodes that we have in here. What are they? So basically this is going to be one node, which is same as this one, so the whole thing can be considered as one node. This is going to be another one. Here's another one and another one in here, which is same as that one. So this whole thing is one node, this is one node, and same thing in here. This whole thing can be counted as one node because they're basically going the same thing. So let's call this one node first, and based on the Kirchhoff law, the sum of all currents entering has to be equal to the sum of current exiting. So here we can see that all three are exiting and there's nothing that is entering this node. So basically we have 7 plus 3 plus I2 equal to the current that is exiting, which is 0 because they're all the current that are entering, which is 0 because all of them are exiting that node. So I2 will be negative 10 amp. So now we can move on to another node. Let's move on to this one right here. Now that we have I2, we should be able to find I1. So looking at that node, we have I1 and I2 entering. So we have I1 plus I2 is equal to what's exiting is the 2 amp that is going that way too. And since we didn't change the direction of I2, we can put the negative value in here. So I1 plus negative 10 is equal to 2. That means I1 is 12 amp. Or what you can do is that based on the previous step, the negative sign that we got in here shows that the direction of I2 is actually to the right. So we can consider this direction in the next step. But once you consider this direction, you have to put the positive value. So up to you. We found I1, we found I2, and now we have to figure out I3. So for that, we can move on to this node. I'm just going to call it node 3. Looking at that node, we can see that we have all these 3, I3, 4 entering that node, and it's exiting with I1. So I1 is equal to 3 plus I3 plus 4. And we figured I1 is 12. So I3 would be 12 minus 7. So I3 is 5 amp, no negative sign. That's the correct direction for I3. And the last one would be the I4. We can pick this node right here. And we can see that we have 2 amp going this way. So we have 2 amp entering the node. So 2 is equal to the exiting is I4 and the 4. So I4 plus 4 amp, which shows I4 is negative 2 amp. And yeah, that's pretty much everything for the first one. Let's move on to the second question. So in this circuit, we need to use the KVL or Kirchhoff voltage law to find the different voltages that we have in here. So for this KVL, as we talked about in the previous videos, we're going to go with the loop or any closed circuit that we have. So if we look at this, we'll see we have 4 loops here. And the only thing that we need to keep in mind is that we're going to go based on the pole that we are entering. If it's positive, positive value. If it's negative, negative value. So we can start from any point. So for the loop 1, we can start from this top part. We're going to get to this point. So we have positive V1 plus passing through this, getting to negative pole of this one, which is our V3, so negative V3, and here we're going to get negative 3, and this will be equal to 0. That's what we get from our first loop. The second loop, let's start from this point. We're going to get to negative V2, And we have negative 2 volts here. And last one here, negative V1 is equal to 0. Another equation with two unknowns, so we're going to move on to the third loop. We can start from here or any points that you want. So here, plus 4, getting back here, plus V3, and here, plus V4 equals 0. And the last loop, again, we have mix of all unknowns. This one we can start from here, so negative V4 plus 2 plus 5, and this is going to be 0. So last equation, we can see that we only have one unknown, so V4 here would be 5 plus 2 or 7 volt. And now that we have V4, we're going to put it in the previous equation 7 here. That's going to give us V3, which is 7 plus 4, 11, so negative 11 volt for V3. And now we have V3, we can put it in the first equation, negative 11 is going to be positive 11. So 11 minus 3 is going to be 8, so our V1 would be negative 8 volts. And now that we have V1, we're just going to put it in the second equation here. So this is going to be negative 8 or plus 8. So V2 would be negative 2 plus 8, which is going to be 6 volts. And yeah, that's pretty much everything for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.